Hi, welcome back. So we're going to look at comparing proportional relationships. So my last video just looked at finding unit rates of tables, of graphs, of ordered pairs. And what we're going to do now is we're going to take that a step further and we're going to compare them. So starting off, question 1. Store A and Store B are each running specials in their stores. The equation below represents the amount of discount for an item that costs X dollars at Store A. So what that tells us right here in our equation, the number that's next to your variable in a proportional relationship is your unit rate or your slope. Okay. The graph below represents the amount of discount for an item that costs X dollars at Store B. So this first one was Store A. This graph is going to tell us about Store B. So looking at this graph, what this tells me, and I'm going to find a nice point we can look at. So I'm going to look right here. What this tells me is that if an item is $20, because that's our X value, we would get an $8 discount. So we're going to do our price. And we're going to look at, and I can't spell today, we're going to look at our discount. So we're going to look at our discount compared to how much that item cost. So they told us our cost was $8 for our discount. Our discount. We get $8 off. Our original price was $20. So what I'm going to do is I'm just going to simplify this and turn it into a decimal, because our first one was in a decimal form as well. So in my calculator, I'm just going to do 8 divided by 20. And that gives me a decimal of 0.4. So we now know this company offers a 0.3 discount and this company offers a 0.4. So let's go see what our question asks us. Which store is offering the greater rate of discount? Greater meaning the biggest discount. Well, if I am comparing these two decimals, 0.3 and 0.4, the zeros are exactly the same. So we move on to the next place value. The 4 is bigger than the 3. So 0.4 is going to be a greater discount, and that was at Store B. So we would say Store B is offering the greater discount. Question 2 is a fun one. They're going to make us compare 4 different situations. So same process, and I'm glad it gave me this question because it's going to show us all of our different representations. So it shows us a table, shows us an equation, a graph, and also just a word problem. So let's start with the table. In this table, what we want to do is we want to look at, we have miles per hour. Looking at the table, I know that if they were going for 70 miles, it would take them 2 hours. I could have also picked 140 to 4 or 210 to 6. I just chose the smaller one. Does not matter. So I'm going to simplify that and find out, what if they were only traveling for 1 hour? And we're going to see what our unit rate would be. So 2 divided by 2 gets us down to 1. To keep this equivalent, we're going to also divide the top by 2. So 70 divided by 2 gets us a unit rate of 35. 35. So situation A, I'm going to write in here that our unit rate is 35. If we look at situation B, we just did an equation just a second ago. We're going to look for that number that's right next to our variable. And that is our unit rate or slope. What we can find is that that one has a unit rate of 30. So right now, what we're looking at is that A is the biggest unit rate so far. When they give you a graph, we're going to do, and we did some of these in my last video, we're going to find a nice, good ordered pair to be able to compare. So, it's kind of hard to see on here. I'm going to follow the graph until I find a nice, neat ordered pair I can use. Now, this graph kind of has only marked every 5 digits, but if I count, there's 5 little spaces in between here. So they're really counting by ones. So this is 1, 2, 3, 4. They just didn't want it to look this jumbled. So they only put every 5th number on there. Save us a little bit of hassle trying to read that. So this ordered pair falls at 1, 10. What that tells me, and I already have a 1 here, is that for one of whatever item this is, whatever this x-axis represents, it would be 10 on our y-axis. That's our unit rate already. I don't even have to do anything else. It's already has a 1 in it. So that is our unit rate. So what that tells me, A is still the biggest at 35. C is now the smallest at 10. So let's look at our last situation. When you have a word problem, you're always going to have multiple numbers to be able to look at and try and decipher. So I'm going to read this. It says, Jack bought 80 seeds for his garden. The seeds come in 4 packets. So we know we got 80 seeds and they came in 4 different packets. So what we are going to do is figure out how many seeds are in each of those packets. So we're going to look at seeds compared to packets. In this problem, he got 80 seeds. They came in 4 packets. And again, we're looking for unit rate. So I want to know how much came in one of those packets. So 4 divided by 4 gives us 1. To keep these equivalent, I'm going to do the same thing on the top. 80 divided by 4 gets us to 20. So that unit rate means that 20 seeds come in each packet. So what you're going to do down here, and this looks a little confusing, is we are just going to drag these tiles down to these boxes. Notice the way these are facing. Okay, the one that's on the left is going to be less than the one that we put next to it, which is going to be less than the one you put next to it, which is going to be less than this one right here. So they tell us least to greatest. Sorry, my handwriting's a little sloppy. So our smallest one was situation C. So we're going to drag this down, put a C right there. You're going to actually drag your tile. I just can't do that. Our next smallest one, if we look, is 20. So that's going to be situation D. So situation D, you would, again, drag that tile down. We've used that one. Our next smallest is going to be situation B at 30. And our biggest is going to be situation A at 35. A way we can double check that is if I write this down. C had a unit rate of 10, which is 10 is less than 20. B had a unit rate of 30, so 20 is less than 30. A had a unit rate of 35. 30 is less than 35. And that's how you find unit rate for all the different types of scenarios that you might possibly be given. That question took forever. All right. Candace and Peter are ordering a pizza for an upcoming party from different pizza places. Candace is trying to decide how many pizzas she wants to order from Pizza in the Sky. So that's Pizza in the Sky. If she orders 2 pizzas, it's going to cost her $11.98. If she orders 3 pizzas, it will cost her $17.97. Now, 2 different ways you can solve this problem. We can set up a ratio because obviously we know if she does not order pizza, she's not going to spend any money. So I know this is a proportional relationship because it starts at the origin. You don't order pizza, you're not spending money. So what we could do is just set up that ratio and divide these, and I will show you that in just a minute. The other interesting thing they did is they gave you 2 pizzas and 3 pizzas. If I subtract those two, I'm buying 1 more pizza on this situation. So we could just subtract those costs as well. So I will do that both ways for you. So if I'm looking, I'm gonna write Candace over here, and I'm hoping you all can see. Can't tell how far. Okay, got a little bit of room. If I'm looking at Candace's situation, it's gonna cost her $11.98 for 2 pizzas. If I want to figure out how much 1 pizza costs, I'm going to divide that by 2. In order for that to be equivalent, I got to also divide the top by 2. So $11.98 divided by 2 means that she is paying $5.99 per pizza. Now, again, because these are only 1 apart, 2 pizzas and 3 pizzas, we could subtract these totals. So $17.97 minus $11.98. And what you're getting is also $5.99. So we're getting that same answer for both of those. All right, so that means that at Pizza in the Sky, it costs $5.99 per pizza. So let's look at Peter's situation. Peter created the table below to determine how much X pizzas would cost for Mike's Pizza. So if we look at Mike's Pizza and Peter's table, what we're going to notice is that this also increases by 1 every time. So he said, well, what if I only get 5 pizzas? Well, what if I get 6 pizzas? What if I get 7 pizzas? And then we have our costs over here. So I'm going to do the same scenario where I subtracted these because these are 1 apart. When I subtract these 2 costs, that's going to tell me how much that 1 extra pizza cost Peter. So what I'm going to do is I'm going to look at 5 pizzas, which was $29.95, minus 4 pizzas, which was $23.96. So $29.95 minus $23.96 also happens to give us $5.99. So what that also means is that Mike's Pizza Company is $5.99 per pizza as well. So what we can find looking at our question, who will pay the cheaper price for pizza, they are actually going to pay the same price this time, because both companies charge $5.99 per pizza. All right, looking at question 4. Harry and Matt are using different printers to print a lengthy research project. Both printers print at a constant rate. So that means that every second, every minute, every hour, they're spitting out the same number of pages. Okay, it's not changing. So after 40 seconds, Harry prints 5 pages. The number of pages Y that Matt prints after X number of seconds is represented by the equation Y equals, I'm going to rewrite this because it's hard to see, Y equals 1/6 X. All right, so which statement correctly describes the number of pages that they can print in 120 seconds? So we're going to set up a ratio again, and we're going to look at if he prints 5 pages in 40 seconds. But I want to know how many he could print in 120 seconds. We're going to scale this ratio up. So we're going to try and get this to 120. Now I know that 40 times 3 is 120. So times 3. Which means I'm also going to take our top of our ratio and multiply it by 3. And we all know that 5 times 3 is 15 pages. So I know that Harry can print 15 pages in 120 seconds. So let's see what Matt could do. The number of pages Y, they tell us that Y is our number of pages after X seconds. Here we have seconds. We're going to plug that in the X in our equation. So y equals 1/6 times 120. So I'm put that in my calculator. 1/6 times 120. That means that Matt could print 20 pages. So Harry could print 15, Matt could print 20. So this says Harry can print 5 more pages. If I look at this, Harry prints 15 pages and Matt prints 20. So Harry is not printing more. So we're going to go ahead and cross that out. This one says Harry can print 2 more pages. Again, Harry's not printing more. Matt can print 2 more pages. If I subtract these, 20 minus 15, that's a difference of 5 pages, not 2. So we're going to go ahead and cross that off, which leaves us with the fact that Matt can print 5 more pages than Harry. All right, last question in this section. Both Mary's Bakery and Andrew's Bakery are running special discounts. The equation below represents the amount of discount on an item that cost X dollars. At Mary's Bakery, Y equals 0.13x. The equation below represents the amount of discount on an item that costs X dollars at Andrew's Bakery. Y equals 0.19x. Which bakery is offering a greater discount? So we're going to compare these two. So we have Mary at 0.13. We have Andrew at 0.19. And again, those just came from that number right in front of that variable, your unit rate. Or in this case, it's a discount rate. Okay. So looking at these numbers, we're going to start by starting with the 0. If I compare the 0, both those digits are exactly the same. Go to the next digit. That next digit, what do you notice? They're both 1s. They're exactly the same. Once I get to this last digit right here, what we notice is that 9 is more than 3. So Andrew's company is actually offering a greater discount because 0.19 is greater than 0.13. So we need to look at these. There's not enough information to tell. Not true. Their discounts are the same. Not accurate. Andrew's Bakery is offering a greater discount rate. Thanks, guys. Hope this was helpful.